Hi. In the Cartesian coordinate system, the points on the plane are identified by their distances, by their x and y coordinates, which are their distances from the x and the y axis. But the Cartesian coordinate system is not the only coordinate system. Here's another one, which is called as the polar coordinate system, in which the points on the plane are identified by their distances from the origin, which we show as r, and the angle between the line connecting the point to the origin and the positive part of x-axis, which is this angle, and we show as theta. So r and theta are the coordinates of points in the polar coordinate system. Let me for instance, the points which distances from the origin is 1, are on a circle which center is the origin and radius is 1. Okay, but the theta identifies each point because each point got a different theta. For instance, this point got this theta, this point got this theta. Okay, so for instance, the point, say 1 and 3 pi over 4 is this point because its distance from origin is 1 and its angle is 3 pi over 4. Okay, but why we need the polar coordinate system? Here I'm going to give you 2 reasons. The first one is that, sometimes, particularly in celestial mechanics, we deal with central forces. So, which are central gravitational forces. For instance, the gravity force the sun exerts on the earth. This is the sun and this is the earth, which depends only on their distances. So why should we bother with the x and y coordinates? For instance, the gravity force here is just a function of distance. And why should we write it as fx plus fy? It's x and y components. For instance, if we need to find the acceleration or velocity of the earth, we should, one way is writing it as this, which is harder, while we could write it as just a function of r in the polar coordinate system. Okay, it was the first reason. And the second reason is that, for instance, some equations or relations in the polar coordinates are, way simpler than the same equation or relation in the Cartesian coordinate system. For instance, this is okay, this is the equation of a curve in the polar coordinate system. In the Cartesian we had y as a function of x, but here we got r as a function of theta. Okay, but the equation of the same curve in the Cartesian coordinate system is this: b11 x squared plus y squared to the 11 plus b10 x squared plus y squared to the 10 plus dot 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 all the way to b1 x squared plus y squared minus a to the 20 x squared equals to 0. This would be the equation of this curve in the Cartesian coordinate system, which got 12 terms. Okay, but one more thing here is how to convert equations between the two coordinate systems. This is our point, this is r, this is x, and this is y, and this is theta. So from here, this is a right triangle, so from here cosine theta equals to x divided by r. And what is r? R equals to the square root of x squared plus y squared. Okay, and similarly sine theta equals to, sine theta equals to y divided by r, which is y over the square root of x squared plus y squared. This is x, this is y, so x squared plus y squared equals to r squared. So r would be the square root of this. So for instance, this is the equation of a circle which center is the origin and radius is a. So let's convert it to the Cartesian coordinate system. Let's write it in the Cartesian coordinate system. So r would be, r is x squared plus y squared. The square root of it is a. So from here let's square the both sides from here. This would be equal to a squared, the equation of a circle. I give you more equations of the curves in the polar coordinates in the next video. In the next videos, also integration in the polar coordinates. Thanks for watching.